the last subtopic for chapter 2, which is the improper integrals. Okay, this topic cover two subtopics, which is integral over infinite intervals, which is the type 1 for improper integrals, and the second one for type 2, the integrals whose integrands become infinite. Okay, let's look at the learning outcome. Okay, two learning outcomes. First, integrals over the infinite interval of integration. And then to find the second one is to find the improper integrals whose integrands become infinite within the interval of integration. So untuk ni, okay, this is for type 1, type 1 improper integrals, type 1. And then this one is type 2. Okay, so two learning outcome. Okay, let's look at the introduction for improper integrals. The improper integrals comes from the definition from the definite integrals. Okay, this is the equation for definite integrals where integration of fx, okay, from interval a until b, where the interval for a until b, a and b is a finite interval, finite, and that the limit that defines the integral exists. That is, the function f can be integrated. So in this topic, the main objective is to extend the concept of these definite integrals, okay, to allow for the infinite interval. And integrands with vertical asymptote, or we can call the vertical asymptote is infinite discontinuities. So we expand this definite integral into the improper integrals, where improper integrals consist of infinite interval of integration and infinite discontinuities. Okay, let's look at the example for improper integrals. Okay, the first one is improper integrals with infinite intervals of integration. Okay, infinite intervals of integration means infinite means the one of the interval consists of infinity. Consists of infinity, the interval for the integration consists of infinity. Okay, by looking at the first one, the interval is between 1 until infinity. And the second one, the integration of exponent x from negative infinity to 0. And the third one, the interval is from negative infinity to positive infinity. So we have to use the concept of improper integrals to integrate this function. Okay, then the second one is improper integrals with infinite discontinuities in the interval of integration. So, okay, based on these infinite discontinuities, okay, we look at the function of this integral. But look at this function 1 over x squared. 1 over x squared. So 1 over x squared means we cannot solve 1 over 0 and 1 over 0. The interval is between negative 3 until 3. So 0 0 is between this interval. So we cannot solve 1 over 0. That's why this function we must integrate using improper integrals. So to integrate this function, we have to separate into two parts kat sini. Means kat sini 0 ni discontinuities, this function fx is discontinuities, is discontinuous at x equal to 0. So we have to separate this integral between negative 3, 0, 1 over x squared, plus plus 3, 0, 0 until 3, 1 over x squared dx. This is second types of improper integrals. And then second example, by looking at this function, normally we look at the denominator. For denominator part, x cannot equal to 1 kan. This function is discontinuous at x equal to 1. X equal to 1. Means this interval is discontinuous at x equal to 1. So we have to use the concept of improper integrals. So kita akan tengok later how to integrate this improper integral. And the third one, the integral of tangent x. So for tangent x, the interval cannot, so we cannot find the tangent pi over 2. Pi over 2. So we have to use the concept of improper integrals. We cannot solve this integral directly. Kita boleh terus integrate. And the third one, the improper integrals with infinite discontinuities and infinite interval of integration. The third one is the combination from 1 and 2. So untuk ni, we look at the interval. Interval is an infinity and also 0. The function is cannot solve 0 and so we have to solve using the improper integrals. The second example. So consists of negative infinity and positive infinity, and also this function is discontinuous at yang tadi discontinuous at x equal to 0 kan, ni discontinuous. Yang ni discontinuous at x equal to 3. Dia macam ni. Third example is consists of infinity and also this integral cannot be solved for interval pi over 2. Kat sini pi over 2. So discontinuous kat sini discontinuous at pi over 2 at x equal to pi over 2. So this is third one is combination from type 1 and type 2. Let's look at the difference between proper and improper integrals. For proper integrals, we can solve this integral directly. Just substitute the interval. Interval 1 until 2. So the solution is ln 2. For these improper integrals, Okay, the problem is at this interval 0, 0. This function is discontinuous at the interval x equal to 0. So we can solve this function using improper integrals. So this is the difference method lah. For improper integrals, we have to use the concept of limit to solve this integral, to solve this integration. This is the difference between proper and improper integrals because of this interval. This function is discontinuous at x equal to 0. You have to use the concept of limit lah. Okay, let's look at the type of improper integral. Okay, type 1 is the infinite interval. When the integral consists of infinite interval, okay, if the integral of fx from a to t exists for every t greater than or equal to 0, equal to a, the integrals of this function fx from a to infinity, we look at this interval from a to infinity, then we can we solve this integration using the improper integrals. We have to use the concept of limit. So ni you akan applykan limit lah. Limit t approach infinity. Okay, so untuk yang tadi the upper interval, we substitute by using t. So from a to interval t of fx, where t approach infinity. Okay, b if t less than b. So the integral of fx is from interval negative infinity to b. So look at this, the lower interval is negative infinity. So you have to apply the limit lah, limit t approach negative infinity. You all kena gunakan concept of limit. Kita tak boleh terus direct integrate this function. Kalau dia ada interval infinity and negative infinity and infinity. Okay, so ni from t to b lah, where t is approach negative infinity. Okay, the improper integral of a and b is converged if the limit exists. And if the limit does not exist, so it is diverged. Okay, the limit does not exist, it means the solution for this integral, you have the solution is infinity. So kalau you dapat infinity, so dia adalah diverge lah. The limit of this integral is infinity, so the conclusion is diverge. Untuk yang exist ni, you akan dapat dia akan dapat any real number lah. Ni any real number. The solution is any real number. Okay, see if both a and b are converged where a is any real number. Okay, this is the interval, the integral for fx consists of interval negative infinity to infinity. So we have to separate into two terms where the interval is from negative infinity to a. A, we can let a is any real number. Let a any real number equal to any real number. Plus the integral of fx from a to infinity. A ni sama lah any real number. So you are kena separate into two parts of interval lah kat sini. Okay, the improper integrals for this one, okay, converge if both terms converge. Both term converge lah, maksudnya term pertama dan term kedua ni converge, you all dapat real number dua-dua ni, baru dia converge. If either one of this term is diverge, means contohnya kat sini you all dapat real number one ni jawapan dia real number kan. Okay, yang ni you all dapat infinity. So the conclusion is this function is diverge. Untuk ini dia mesti dua-dua ni dapat real number, baru conclusion dia adalah converge. Maksudnya kita tak boleh add on, kita tak boleh tambahkan infinity lah. Kalau real number plus infinity, kita akan dapat solution dia infinity kan. So that's why conclusion dia diverge lah. So infinity. Contoh real number plus infinity. So dia adalah infinity. Okay, ada soalan tak? Untuk definition ni. Sebelum kita tengok contoh calculation. Ni definition eh. Tak ada eh? Okay, so kita tengok example 1. Ada soalan?
Ini fahami madam, tak ada.
Okay, boleh. Okay, example 1. Okay, evaluate this function 1 over x from interval 1 until infinity. Okay, so kat sini ada infinity lah. So automatic awak kena guna konsep improper integral. Okay, so kita boleh let lah, let t limit t approach infinity. Okay, the integral of 1 over x dx from 1 to t. Where t kat sini, t is infinity yang tadi kan. Same. Okay, then salin balik lah. Limit t approach infinity. Then you all integrate this function 1 over x. 1 over x is ln x. So from interval 1 until t. And then apply kan t, substitute the interval. Okay, ln t, okay, minus ln 1. Okay, then we substitute the value of t equal to infinity kat sini. Substitute lah kat sini t equal to infinity. T approach infinity. Gantikan je lah. So ln infinity minus, okay, ln 1 is 0. Okay, so kat sini ln infinity is infinity. So the conclusion is diverge. Ya, mesti kena buat conclusion dia ni, diverge. If the solution is infinity, so diverge. If solution is real number, so converge. So we look at these tips lah. Tips ni kena tahu ni. Tips ni. Kena tahulah ln 0 is negative infinity. Sebab dia akan effect lah kan. Kalau buat ln 0 ni positive infinity, salah lah dia negative infinity. Ln 0 is negative infinity. So exponent negative infinity is 0. Okay, ln infinity, then exponent infinity is infinity. Okay, ln 1, 0, exponent 0 equal to 1. Yang ni kena ingat. Banyak akan digunakan lah untuk ni improper integrals. Okay, second example. Okay, the difference between kat sini lah, the interval function still sama, tapi beza dekat dia punya interval ni. So interval from negative infinity. Tadi positive infinity kan. Okay, ni negative infinity. Okay, so we apply the concept of limit. Limit t approach negative infinity, where the interval is from t to negative 1 of a function 1 over x. So sama lah tadi, you all integrate this function 1 over x, integrate this function with respect to the x. So we get ln x. So interval from t to negative 1. Okay, and then substitute the interval. Okay, ln negative 1 minus ln t. Okay, untuk ln, sebelum ni kalau ada sebelum ni kalau ada ln tu kena gunakan modulus kat sini. Kena apply kalau ada ln, applykan modulus. Apply modulus. Solution untuk kalau dapat ln kan, integrate 1 over x. Kalau ada dapat ln, nilai ln tu moduluskan untuk ln. So ln negative 1 minus ln t. Dan ni substitute t equal to negative infinity. So ln negative 1 akan jadi ln 1. Okay, minus ln infinity akan jadi positif juga, ln infinity. So ln 1 is 0, 0 minus infinity is negative infinity. So it is diverge. Ni kena tulis conclusion untuk ni, diverge. So the effect kat sini lah kalau modulus ni kan. Kena moduluskan. Okay, ada soalan? Tak ada? Boleh faham Tak faham boleh terus tanya. Ya?
Yang apply modulus ni untuk topik ni saja ke ataupun semua?
Semua. Sebenarnya saya tak terlupa nak bagi tahu kan. Semua kena, untuk ln kena apply untuk semua lah.
Okay, madam.
Topik sebelum ni pun kalau ada ln kena dimoduluskan lah.
Okay, terima kasih.
Okay. Okay, ada lagi soalan? Tak ada. Tak ada, saya sambung ni. Okay, example 3. Okay, evaluate 1 over 1 plus x square from negative infinity to infinity. Okay, so untuk yang ni, you all kena separatekan kepada 2 lah. So untuk yang ni, separate tadi a kan? Negative infinity to a plus a to positive infinity. So a kat sini can be any real number. Contohnya a untuk can be any real number ni, mestilah kat sini awak tak boleh. Ni boleh, dia tak boleh 1 over 0 lah kat sini kan. Contohnya kat sini kalau ganti negative 1 pun, mesti boleh jugalah. So ni any real number lah. Dia depend kepada function kat sini lah. So ni contohnya dia ambil negative infinity to 0 of this function plus dengan the integral of this function from 0 to positive infinity. Okay, then kat sini you all kena solve separately lah. Dia ada 2 term kat sini, 1 and second term. So kita tengok dulu untuk first term. From the integral of 1 over 1 plus x square from negative infinity to 0. Okay, we apply the limit where t approach negative infinity. Then we integrate this function 1 over 1 plus x square is tangent inverse x. So the interval is from t to 0. Then you substitute the interval into this function. Okay, and then apply t equal to negative infinity of this. T equal to negative infinity. So we get tangent inverse 0 is 0 minus tangent inverse negative infinity. So untuk yang ni, for the tangent inverse, ni pun ada tips dia untuk yang ni. Just apply kan je lah untuk yang ni. Tips for tangent inverse 0 equal to 0. Tangent inverse infinity equal to pi over 2. Tangent inverse negative infinity equal to negative pi over 2. Yang ni kena tahulah yang ni tips dia. Awak boleh take note sikit lah untuk yang ni. For the tangent inverse. Okay, so tadi tangent inverse in negative infinity is negative pi over 2. So the solution for first term is pi over 2 kat sini. Pi over 2. Boleh. So kita dapat real number kan untuk term yang pertama. Then awak kena cari term yang kedua. Dia mesti kena cari yang lagi satu term lah, term yang kedua. Contohlah untuk term pertama ni awak dapat nilai infinity. Kita tak perlu cari term yang kedua lah. So automatic the conclusion is infinity lah, diverge. Ni sebab awak dapat real number, so kena cari yang kedua. Okay, so untuk yang kedua ni, the interval is from 0 to positive infinity. Masukkanlah t and 0. So tangent inverse infinity is equal to pi over 2 minus 0. So jawapan dia pi over 2 untuk second term. Okay, and then last one ni kita tambahkan lah kedua-dua term ni. Pi over 2 plus pi over 2. So we get pi of the solution is equal to pi. So it is converge. Kena tulis conclusion converge. Okay, boleh? Boleh?
Boleh, madam.
Boleh. So this is the formula for operation of infinity. Ni you boleh tengok sini for addition and subtraction and also multiplication of infinity. Macam yang tadi lah. Kalau dapat infinity plus real number, we get infinity. So infinity tu diverge. Boleh tengok ni negative infinity plus a and real number is negative infinity. Yang solution untuk ni pun nak kena take note jugalah operation dia. The sign for infinity. Take note untuk ni. Let's look at the type 1 for improper integral consists of discontinuous integrand. Okay, definition: if f is continuous on the interval a and b. Okay, by look at this function, the integral of fx from a to b, but this function is discontinuous at x equal to b. Ni discontinuous at x equal to b. So we solve this integration using the concept of limit, because this is improper integrals. So we have to apply the limit for the limit integration of fx from a to t T, the upper interval is discontinuous where T approach B negative. So untuk upper interval kita gunakan B negatif lah. Ni nak untuk bezakan je upper and lower interval. T approach B negative. Okay, for B ni F is continuous on A and B but discontinuous at the lower interval. Lower interval. So we have to apply the concept of limit where T approach A positive. So untuk lower interval dia akan jadi T approach A positif lah. Dia akan jadi positif kat sini. Ni untuk bezakan nak punya interval lah. Ni B positif. Okay, if the solution exists, so this function is converged. And if you get the solution equal to infinity, means the limit does not exist, therefore it is divergent. Conclusion dia sama macam yang tadi lah. Okay, see if F is discontinuous at C. C means discontinuous at the interval between A and B. Kat sini. Dia discontinuous between A and B kan kat sini. So we have to separate this integral between two parts kat sini. Part 1 and part 2 macam tadi. Into two terms lah kat sini. Between A until C. C is the interval of the interval for discontinuous at C plus C until interval B. Then solve using the concept of limit lah. Kena guna limit lah macam biasa. Saya kena apply limit. So conclusion dia sama juga macam tadi. If the limit for first term consists of infinity, so the conclusion is diverge. If the limit for first term is real number, so you have to find the second term lah. If the limit is exists, therefore it is converged lah untuk ni conclusion dia. If either one is the limit does not exist, so it is diverge. Conclusion dia sama untuk macam yang tadi, yang type 1. Okay, example 4. Okay. Integral of 1 over square root 1 minus x dx from the interval 0 until 1. So first we have to check the discontinuous. Kita check dia punya denominator. Kita tak boleh 1 over 0 kan, this function cannot be 1 over 0. So this function is discontinuous at x equal to 1. Kita equal to 0 lah kat sini, equal to 0. So equal to 1 means the problem dekat interval ni lah, the upper interval kan, the upper interval. So we have to apply the limit lah, limit t approach 1 negative. Untuk upper interval tadi negatif kan, dia jadi sign negatif. So integration from 0 to t of this function. Okay, then to integrate this function 1 over square root 1 minus x, we have to apply the substitution, u substitution. U substitution. Okay, that u 1 minus x and then du equal to negative dx. So negative du equal to dx. Okay, we substitute. We convert this function in term of x into in term of u. Supaya kita lagi mudah nak integrate dia lah in term of u ni. Kita gantikan in term of u. So akan dapat ni integral of u negative 1 over 2. And then we integrate this function in term of u. So kita akan dapat 2u power 1 over 2. And then we substitute back the value u equal to 1 minus x. Substitute balik u equal to 1 minus x. So we get this function. And then we substitute the value, the interval x equal to t and interval minus interval x equal to 0. Okay, then we substitute the value 1 minus t, the value of t equal to 1. Kita 1 negatif, tapi kita ambil negatif ni, either negatif ke positif ni nak tentukan dia punya interval je, either upper or lower interval, tapi kita still ambil, kita substitute t equal to 1 lah. T equal to 1. So akan dapat ni 0 lah, 0. Dan ni minus 1. So equal to 2. 2 is converge. Ni kena tulis Okay. Untuk example 5 ni untuk lower interval. Dia discontinuous at lower interval kan. 1. X equal to 1. So dekat lower interval lah. Sama lah. Untuk lower interval kita akan gunakan limit t approach 1 positive. 1 positive. Okay, so untuk yang ni kita applykan u substitution. Sama u substitution. Okay, kenapa you all applykan u substitution? Okay, sebab kat sini kalau terus kita buat ln u, salah lah, dia tak akan dapat, dia jawapannya salah sebab kat sini x dia equal to negative 1 kan. Jadi kena gunakan u substitution lah dulu. Tak boleh terus apply kan. That's why kat sini dapat negatif. Oh ni sebenarnya salah ni. Negatif du equal to dx kan. So dx kita substitute dx. So ni equal to du. So negatif 1 over u du. Negatif du over u sebenarnya. Ni dia sama dengan ni lah, negatif du over u. Kita gantikan nilai ni kan. So then integrate. We get negative ln u. Then gantikan nilai interval dia. Ln 1 minus 2 minus ln 1 minus t. Then awak gantikan kat sini t equal to 1. Okay, so tadi solution dia ln negatif 1 kan. Negatif 1 dia akan jadi positif lah. Negatif ln 1. Okay. Plus. Ni jadi plus lah. Ni minus ni kan. So akan jadi plus. Ni sepatutnya plus ni. Plus ln 1 minus 1. 0. So negative ln 1 plus ln 0. Okay, negative ln 1. Okay, ni posisi tadi. So 0 ln 0 is negative infinity. Ni guna yang tadi, tips yang tadi, non-zero tadi yang awal. Dan ya, ramai kadang-kadang student kadang-kadang tersilap kat sini lah, non-zero you all buat infinity je. So salah lah, non-zero adalah negative infinity. Take notes dekat situ lah. That's why answer dia negative infinity. Dia akan effect lah kalau awak jawab positive infinity tu tak dapat full mark lah. Diverge. Conclusion dia still kena buat diverge. Walaupun betul kan diverge kan. Tapi kat sini jawapan akhir dia ni. Okay, boleh? Ada soalan? Ada soalan? Boleh faham?
Boleh, madam.
Boleh, madam.
Boleh? Ni saya tidak contoh je lah. Okay, number 6, example 6 ni. Ni kita check discontinuous at x equal to 1. Okay, yang ni discontinuous dia dekat tengah-tengah antara interval 0 between 0 until 3. Dia discontinuous kat x equal to 1 kan, tengah. So kat tengah ni you all kena separatekan kepada 2 lah. Interval from 0 to 1 plus the integral of function between interval 1 until 3. Sebab dia discontinuous at x equal to 1 kat tengah ni. So kena separatekan kepada 2. Kepada term pertama, term yang kedua. So apply, kena solve dua-dua lah. Okay, try solve dulu untuk yang pertama ni. Okay, yang pertama pun sama macam sebelum ni. You all kena applykan limit, concept of limit sebab dia adalah improper integrals. So dia kat sini dia discontinuous at upper interval kan. Upper interval. So kat sini t equal to t approach 1 negative. Okay, then guna use substitution or solve 1 over u, akan dapat ln u. So ni masukkan interval dia t minus interval equal to t minus 0, masukkan t minus 1 minus ln 0 minus 1. Okay, then ni gantikan t equal to 1. So ln 1 minus 1 minus ln negative 1 dia akan jadi positif minus ln 1. Ini ln negative 1 sama dengan ln 1. So ln 0 is negative infinity minus 0. So negative infinity. Okay, dah dapat jawapan dia does not exist kan sebab infinity. So you all tak perlu nak cari untuk second term ni. Tak perlu nak cari yang ni. Do not need to evaluate the second term because the first term is diverge. So this implies that the integral for this function from interval 0 to 3 is diverge or divergent. Itu about conclusion. Tapi ini kena betul lah untuk first term ni kan. So negative infinities. That's why kat situ kena betulkan untuk ln 0 ni. Ln 0 is negative infinity. Example 7. Okay, ni sama juga macam tadi. Kita perlu check dia punya ni, denominator ni. So x minus 2 power 2 over 3 equal to 0. And then x equal to 2. So discontinuous at x equal to 2. Dia ada kat tengah ni juga. 2 kan. So we have to separate into two terms. Term 1. So 1, interval 1 until 2. And then second term, the interval 2 until 4. Okay, then kita solve dulu untuk first term. Okay, so kat sini discontinuous at upper interval. So that's why kita gunakan limit t approach to negative. From interval 1 until 3. Okay, so kita integrate this function. Kita tukar kepada u substitution. Ni u substitution. And then we integrate this function in term of u. So we get 3u 1 over 3. Okay, then we substitute back the u equal to x minus 2. So dia akan dapat balik in term of x lah. The value in term of x. Okay, then baru you dah dapat in term of x, baru you all applykan the interval. So substitute x for upper interval, t minus 2 over 1 over 3 minus the lower interval, 1 minus 2. Okay, then ni gantikan t equal to 2. T equal to 2. So 2 minus 2 minus, okay, 1 minus 2. So ni dapatlah 2 minus 2 0 minus, so ni minus negative 1 kan. So akan jadi plus 1. So equal to 3 untuk first term. Okay, dapat nilai ni real number. Then you all kena cari second term. Okay, second term for interval 2 to 4. Sama juga macam tadi, masukkan ni just tukar dia punya interval lah. 2 to 4. So t to 4. Masukkan. And then tukar, substitute t ni equal to 2. So solution f 2 1 over 3 minus, ni substitute 2. So akan dapat 0. Okay, so solution to second term 3 times 2 to the power of 1 over 3. Okay, then tambahkan dua-dua. We add on these two terms. First term plus second term. So the solution is converge. Because the limit exists. Okay, so this is the last example for improper integrals. So summary for integration. Now you have learned types of proper integrals. Yang sebelum ni lah, using you all dah solve the various types of integration using integration by parts, substitution, and so on. And then this last is improper integrals. So improper integrals consists of two types. It's infinite interval and discontinuous integral. Okay, so tu last lah untuk ni. Okay, ada apa soalan? Untuk soalan dalam notes ni? Ada? Boleh faham?
Boleh, madam.
Boleh. Okay, so ni tutorial Okay, tutorial. Boleh tak? Cuba buat ni. Okay, kita tengok contoh satu tutorial ni. Satu ke dua ke? Tengok contoh. Okay, soalan first ni. Okay, explain why this integral. Okay, 2 over x minus 1. The integral for interval 0 until 3 is an improper integral. Kenapa? Kenapa ni improper integral? Boleh jawab tak siapa-siapa volunteer?
Sebab antara 0 dan 3 tu ada nilai 1. Kita kena selesaikan dulu x tolak 1 equals to 0 dulu. Lepas tu dapat nilai 1. And 1 tu adalah di antara 0 sampai 3. 0 hingga 3.
So satu tu ada nilai apa? Fx is discontinuous lah. Ni untuk type yang kedua lah kan? So because fx is discontinuous. Discontinuous fx equal to 1. At x equal to 1. Daripada ni lah. Ni types yang kedua lah tadi. Ni types pertama. Dia kat sini lah. Dia antara ni kan. Ni types yang kedua yang dia tengah antara ni. Yang C ni. So untuk ni solution evaluate this integral kan. You all kena pecahkan kepada dua lah yang ni. So pecahkan 0, 3, 2 over x minus 1 dx. Okay, equal to, kena pecahkan 0, 1, from interval 0, 1, 2 over x minus 1 dx. Okay, plus 1 until 3. Okay, dan kita solve dulu untuk yang pertama ni. Bahagian yang pertama. Part first term ni. Selesaikan ni dulu lah. Okay, selesaikan ni kita applykan limit lah ni kan. So, 1, 0. Kita kena applykan limit. Dia discontinuous dekat ni kan. X equal to 1. So, we apply the limit. Okay, T approach kalau untuk upper interval negatif kan. So, 1 negative. 2 over x minus 1 dx. Then, ni lah. Integrate ni. Ni boleh gunakan u substitution juga kan. Let u equal to x minus 1. So du equal to dx. So akan dapat 2 over u du. Akan dapat limit t approach 1 negative. Okay, 2 ln u. Sama dengan limit t approach 1 negative 2 ln x minus 1. From interval ni gantikan interval tadi 0 to t ke sini. 0 to t. So 0 to t. Gantikan lah, masukkan t ni. So dapat 2 ln t minus 1 minus lon. Okay, substitute 0, negative 1 kan. So, dia jadi positive 1. Gantikan. So, gantikan 2 lon. Gantikan T equal to 1. Akan dapat ln 1 minus 1, 0. Minus 2 ln 1. Ln 0 dapat negatif infinity kan. Ya boleh. Ya. Tu negatif infinity kan. Minus 2, 0. Jawapan dia negatif infinity. 2 times negative infinity. Kita tengok yang tadi 2 times negative infinity. Mana tadi yang table tu? Negative times real number is negative. So jawapan dia negative infinity. Kita tak perlulah cari the second term. So it is diverge. Conclusion diverge. Conclusion untuk ni lah. Untuk integral 0, 3. 2 over x minus 1 dx. Is diverge. Sepatutnya ni negative infinity. Ni mungkinlah dia buat. Ni awak boleh buat terus conclusion lah. Cari satu ni dapat negative infinity sepatutnya kan. Ni kalau ada jawapan yang salah kan nanti boleh bagi tahu saya. Kadang-kadang dia salah dekat dia punya sign untuk infinity ni. Nanti awak kena check sign untuk infinity. Yang ni tak pasti untuk sama ada dia combine. Kalau combine pun term lagi satu positif. Tak tahulah ni mungkin dia cari term lagi satu kot. Positif jawapannya ni. Term lagi satu dapat positif. So kalau negatif infinity plus infinity, ada jawapan dia ada dua kan. Negatif infinity plus infinity is equal to ni. Infinity plus infinity betulnya. Ni mungkin jawapan term yang kedua kot ni. Conclusion dia diverge. Yang kedua tu dapat infinity. Term yang kedua je ni. Term yang kedua yang ni lah. Kalau cari term yang kedua kat sini jawapan yang ni jawapan infinity lah. Boleh salah satu lah ni. Ini awak dapat infinity. Nanti ni awak cuba buat number 2 ni. Cari nilai value M. Okay, cuba tengok nombor 3. Tengok lagi satu contoh nombor 3 ni. Tadi buat nombor 1, nombor 3. Okay, determine whether this improper integral converge or diverge. First awak kena check dia punya ni lah. Denominator dia kan, integrand. So dia discontinuous at x equal to 1. Ataupun okay, untuk yang ni perlu ke? Kalau yang ni tak perlu check lagi sebab ini terus dah ada infinity kan. Terus je lah buat infinity. So terus approach. Limit T. Dia terus tengok infinity lah kat sini. Dia punya, sebab dah ada dia punya interval, upper interval is infinity. So T approach infinity. From infinity to 2. Sebab kalau kat sini 1 dia interval dia 2 until positive kan. 1 dia bukan between 2 until positive, infinity. Sebab dia interval dia start dia 2. Kat sini. So kita tak perlu check yang ni lah. Dia sebab within 2 until positive. Dia tak cover untuk 1. Jadi awak terus gunakan yang ni lah. Dx. Then integrate ni akan dapat limit kuasa 2. Ni kena applykan U substitution lah kan. Let U equal to 1 over X. Du equal to X minus 1. Du equal to dx. 0 infinity 1 over U square du. So integrate ni akan dapat negative 1 over U kan. Negative akan dapat ni negative 1 over U. So terus gantikan kan. So terus gantikan. So 1 over X minus 1. Okay, so limit dia from 0 to T. Okay, yang ni T ganti T. So ada guna T kan. Dah gantikan T approach infinity. Then negative 1 over T minus 1 minus plus 1 over negative 1. Limit dia apa tadi? 2. Oh silap. 2. 2. So 2 minus 1 is 1. Dan gantikan is infinity. T equal to infinity. So akan dapat negative 1 over infinity kan. Plus 1. Negative 1 over infinity is 0. So 0 plus 1 equal to 1. So dia ada